Hello. Hey. Good afternoon, everyone. It's a Monday. It's a July 9th. It's 12:06 p.m. and oh my god, I'm tired. Yeah. So, let's get this camera rolling. Hey. Hi. You know those weeks when you're like not in the mood to do anything? I'm in the mood to do some stuff, but my eyes are just closing. I've got two cats napping right next to me, and I really want to join them. I just like downed a whole burrito bowl, three quarters of burrito bowl, and my God. Mm. But we're not gonna fall asleep today. We going to do some Rust stuff as per usual. I've got like a couple projects I'm like curious of doing. I just wrote this little shell script, which is kind of fun, which allows me to open up this little window on the left in one command now. So happy about. Yeah, the main goal for today, the work I should be doing is work on this module called Sparts Bitfield. Also, hey, Weiss Grim, nice of you to join. Whew. Yeah. So I should work a little bit on the Bitfield over here, but that's not too much work. It's a little bit of work, and then probably hack on Tokyo stuff, async server stuff. I kind of feel like we need to. How's your weekend been? My weekend was made up out of having a dog over with two cats, and one cat was just like hissing. I was like, kind of. That's my weekend. That was my Sunday. Cooked some food, had some friends over, had some wines. My girlfriend got into a biking accident, got stuck between a bunch of tram tracks, so I had to tend to that. But otherwise pretty good. All right. Okay, more coffee. I just went to the burrito place around the corner. I got some burritos. Well, one burrito bowl and one coffee in my little coffee mug. So I'm really happy. Weissinger says weekend was quite nice, but way too warm. Damn. Yeah, it was pretty hot down here also. Whereabouts are you based? I'm guessing, giving the time zones, probably either Asia, Australia, or EU ish. Oh, there's another continent down there, but Germany. Oh, sweet. Same. Nice. Oh, I guess the grim name might have been a giveaway. Well, all right. So the idea for this thing, can I show you? Can I? I can show you. Code. No, this one. And then the next one is memory pager. So over the weekend, or on Friday, Thursday, something, I made this patch, which says allow creating an instance from a file. Talk. This is kind of nice. Oh, that's not the intention. Bum, 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 bum. All right, so the main thing you can do. Yeah, hey Rihanna, welcome. And the dash dash no depths is So good. Like for some reason, one of the packages I was using just stopped compiling, and I was like, "Fuck!" So I had to dig in and found that one. It just speeds it up in general, so that's really good. Yeah. All right. So the main thing I made is this patch where you can open up a file and then you can create a pager instance from that file. Where you borrow the file and it reads it out, and it gets all the data out, and it says, "Well, here it is." And now I'm what's that? Now it's good. Let's do that, which is good addition. But now we need to pop this one up into the was that memory pager? That was not memory pager. Is that memory pager? God damn it! Did we already? Oh yeah, that's memory pager. All right, so the idea is that we can then add that to our bit field implementation, which means we can provision a whole bit field just from disk. Be like, provision yourself, and it's like, oh yeah, sweet, I'll do that. It's kind of useful. The one downside of that though is what's the downside of that? There's a downside to it. Actually, probably the being able to share a memory pager will solve all of our issues, because it means we okay. Stepping back. So the idea for now is we need a bit field. We create in HyperCore, we create a bit field, which is basically like a binary tree, which allows us to check whether or not we have particular pieces of data, because we just traverse the tree and we're like, oh cool, we have this piece, we don't have this piece, without needing to like do a big search. It just keeps an index onto our data. Now the thing about this index is you want to persist it to disk. So when you get this thing up, you fill it with ones and zeros, right? You fill up the tree, and then I don't know, your computer goes offline, you quit your program, you reboot it, whatever. It needs to recreate that state. So we want to write it to disk, but we also want to read it from disk. And right now, the way the the way the bit fields work is there's 3 bit fields that share one memory space, so one memory pager in the JavaScript version, not in the current version. So what we need to be able to do is accept an RC of bit fields and so a reference counted instance of bit fields, or what was it? No, it needs to be a mutable shared thing. So it's a ref cell around a memory pager, and then the bit field consumes that and is able to like read and write to it from particular offsets. That's the idea. Okay, that is what we want to be doing. All right, so we want to create one memory pager instance that's shared. So allow our bit fields to use it. Okay, hope that made sense. There's an open issue for that here. Also, how's your weekend been, Rihanna? How you doing? I haven't spoken like in ages. Oh no, that's terrible advice. I'm not. That's fucking terrible. I'm so happy that you can't really. I don't know. That's just terrible. Here's the exact description. We need a with pager constructor, preferably one that can operate on a ref cell pager, so we can share the memory backend. So let's do that. So what we got, we update memory pager, failure file from file. That's all right. So if we run cargo check now, so I think from file is reasonable. So pages length, lib, line 54, pages length. So this needs to be is right there. Let page length equals pages.len. Like that. Boom. Cargo check. All problems solved. And now we can create an instance from a file. So I wrote this code the other day, which is pretty straightforward because you have like a from file here. And what it means is we initialize self with some values. Now the one downside is that byte length is unprovisioned, which means we don't know what the length is in bytes. Oh, it's kind of fun. So in this case, the only proper way to know that is, ooh, look at this. That's my computer being like, I don't know if we're still streaming. So it's okay. So the other day OBS segfaulted. I didn't know this. So now all the kernel problems are being like reported. I can get a readout. So I can reboot OBS if it ever crashes, which is useful. All right. So there's just 3 values in here. Pages, which is the actual memory pages. Pages. So here we create a pager from file. So that's pretty straightforward because this wrapper just forwards it. Then there's page length, which is the amount of pages we have. Oh, is it? Is it not? Page size. Yeah, okay, I guess the same. So there's page length here, and then there's byte length, which is the length in bytes. Byte length 0, byte length 0, that's not good. Self byte length equals index plus 1. So what you can know is whatever the index is plus 1. Which I guess is kind of wrong. I'm thinking self byte length times 8, that's length. Blop. So here we have this, and then we say byte length is probably, how does that work again? We have our page size, which is like 1024 bytes, and then we need to times 8 that. Yeah, that should be good. So then we do page size times 8. Page size times 8. Cargo check. Bloop. That works. Page size equals that. And we delete that. And then here we say, nope. Empty pages are initialized. Pages are initialized as 0. So that means that when we reinitialize a page, we essence our byte length becomes the length of the amount of, oh wait, so we have page size times page length. It's page length times page size times 8. Becomes the amount of bytes we have times the amount of pages we have. Is it times 8? It's page size byte length. That's the amount of bytes we have. No, that's actually okay. That's totally fine. So no need to times 8 it because that's the byte size. Byte byte length, like that. All right, cargo check. Hope this makes sense. This might come by back to buy this, but that's okay. Is anyone working on some fun projects? I've literally only been doing that stuff, which is getting kind of blah right now. It's just because it's so much like of the same, and at some point you're like, I kind of want to like have some side projects, some other stuff, dig a bit deeper. I don't know. I haven't been doing that. Byte length, page length times page size, pages length. Bits.set. Oh yeah, there we go. That's actually good. Get the amount of bits in the bit field. All right, which is different from byte length. All right. Get the amount of bytes in the bit field. And then the way we can do this is, all right, that works. Oh, cool. Rihanna says, I've been taking some of my old JSC obfuscation scripts and cleaning them up to publish later. That's pretty cool. Is that the type of stuff where you take obfuscated JavaScript and you try and prettify it? Say someone minified it and you try and like convert it into something more readable, or? Yeah, like that. All right, cool. Sounds pretty useful. Have you done any work on Rust at all with the Browserify rusting? The Rust Browserify? OPEX to individual files. Oh, that's super useful. Oh yeah, I saw your Webpack. What's it called? The Browserify unpack, but then for Webpack, the Webpack unpack, something like that. I think it's I saw it pass by on GitHub somewhere, which looked pretty cool. Do we need to write a test for this? Yeah, I'm not gonna be using that. Yeah, that's one of the parts. Oh, cool. From file. Init from file. Oh my god, this is actually really annoying. Compare and pull request. Allows initializing from file. Thanks. All right, and now for our next trick from Pager. So just take the existing code. Rihanna says, I think I need to spend a lot of time on understand borrowing and stuff to get the Rust Browserify thing to a better place. I haven't spent the time yet. Yeah, that's fair. For what it's worth, probably a month from now, the nightly version of Rust will have like a much better borrowing story, because it'll understand like way more weird, well, just things you would hope it would understand, that makes sense it would understand, that doesn't understand right now. Because right now it determines lifetimes based on block scope. So the only way a borrow is freed is not when you stop using it, it's when the block runs out. So it means any non-trivial code would probably have a version where you're like, but I'm no longer using this variable here. And the answer is, yeah, you need to wrap it in the block scope and return and do some weird stuff. So that's all not great, but it's landing soon. Because do you like have any questions about borrowing? Because I think I might like be able to answer them pretty easily. Because I've created like a good understanding of how it works now. I never run into problems anymore. At least not more than I would like in JavaScript for some prototype stuff or something, right? Which is like, oh, I just need to think about it for a second. Implement bit field, new from file, set. All right, here we go. Not really beyond the one we chatted about back around peer-to-peer day. All right. From pager. So, okay. All right. Sorry, I'm like half falling asleep here. I think I just need to stand up. Ugh. All right. So let me think. So we're going to build this pager method, which we're going to call from pager. If we just sketch out the API, the idea is we return a new instance as opposed to being a method on the instance, which you can recognize by the unmute self, or the first argument would be a self argument. So in this case, pub function from pager. So the first thing it takes is a pager of type pager. The second thing it needs is, we'll take a look at our new. Generally, all you ever need is a page size, but we already have that, so that's good, which means we're done. All we need is a pager. Now, as you might see here, is we're consuming the pager. So instead of borrowing the pager and like giving the instance back, we actually take ownership of that object. Otherwise, it would be like something like that, but it's not. So we take a pager externally and we stick it in this struct in our instance, and then it keeps ownership of that. Now, like I was saying earlier, what we actually want to be doing is be able to share a pager between multiple instances. So we'll need to be using a smart pointer for that, which is called doc.rustlang/standard ref cell, standard cell ref cell. Right. So we create a new ref cell instance, and then we can share that value. Now, ref cell will be implementing a bunch of traits, including the damn it, partial ord equals partial equals sync send default debug. Yeah, it's a bit annoying. Actually, we want the ref mute, a wrapper type for a mutably borrowed value from a ref cell t, which is good. So dref and dref mute. I believe these are the traits we need, which is good enough. Because dref and dref mute, in turn implements, oh, amazing, unpin. Wonderful. Blah, 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 blah. Yeah, the idea for that is, sorry, I'm trying to find the right words. We want to have a thing where we can create an instance from a pager, and the pager can be either a ref cell, or it can be something else. So, trying to find the right words to explain this. Whoops, CPU is still overheating. All right. So the API for that would be is either we create lat bit field equals bit field from pager, just like pager default, which is a own value, right? Or we would do a thing where we're able to borrow a pager, or maybe we have a our pager is right here. Refcell conco new, like that. And then the pager we pass in here is c dot borrow mute of sorts, is a pager dot borrow mute, along those lines. All right. And then we have a we can then pass it into the idea is that we're then able to do that. Whereas in this case, if we tried to pass the same instance into multiple things, we would not be able to. But what I want for the API is to accept any of these versions, because they're all valid, and it doesn't really matter too much, right? I'm okay if it's like a non-borrow type, pretty much. If it just pretends it's owned, which is good enough for me, but yeah, it probably won't work that way. So we'll probably get into what they call lifetime hell, which I like to call lifetime challenges or puzzles or exercises. I'm pretty sure it's possible though. All right. So pager. So what happens when we have pager? Let's do the basic version first. Okay, because the return type should be a lifetime party. Yeah, I like that. Should be a result of self, error. So okay, self pages pager. Let page length equals pages.len. Let byte length equals page length times page size. In essence, the byte length we should actually ditch internally, because we can always compute it, but the value would just change, because this is the way it actually is always updated. Pages pager, page length, byte length. Can't find value. Let's do it like that. Page size. I believe page size is pages dot page size. Yeah, there we go. And because that's just inlined, at compile time, because we've done our job and add an inline attribute. It should be reasonably fast later on. So the pages times page size will probably just be compiled statically, because it's all like constants, so LLVM will know what to do. It'll be like, oh, here's like a static value, a constant value. It's good. Hey, good morning, Dan. How are you? Oh my god, my CPU is so not happy. You're great. That's nice to hear. Happy about that. Instance from a pager. All right, so this works. So what we now want to do is hashtag happy about that. Dun, dun, dun. We want to create a method that's able to be generic over all of them. Construct our C box, T sized, not sized, not sized, not sized. Yeah. So this is a ref mute. Coerce, unsized, display, deref mute. All right. So we're gonna, all of these are passing, so we can just like merge them. It's nice. So the as ref, there we go. Convert as ref, convert as mute. There we go. So I believe this may or may not work for a thing, which I hope. For Vec, for T, for other stuff. I'm not talking a lot anymore. I don't know why. I'm like too distracted. Oh, we should probably put up some light. Hello. Yeah. So the ref cell, if we're looking at the documentation here, so the part where I'm a little bit confused about is the ref cell. It does have deref mute and deref, but it does not have as mute. So what I'm hoping is that deref mute somehow also pulls in as mute, or because it's mutable, it'll just be like, yeah, it's totally okay, but it might just horribly fail. So let's add this. All right. So use standard convert as mute, and then once we have that, we add it using the new impulse syntax, which allows us to just nicely inline it in a single line, and we get an as mute of pager. It's just a bundle of cats hanging out here. Hold on, maybe I can like. No, I need to show cats. That's two cats right there. You might see one pair of eyes looking up. That's it. That's the cats. Burrito bowl. Oh no. Hi. Whoa. Yeah, whoops. Yeah, the cats are doing a little cat nap. They're like, it's hard to even see how the way they're curled up because it's like two little crescent moons squished together. I was kind of hoping they would like hang out in the back, but they're not too interested today, and that's okay. Oops, CPU is still not happy. Should probably figure out how to fix that because it's never a good sign. As mute. All right. From pager. So as mute of pager, that pager equals pages or pages dot borrow or as mute. Sorry. The size for values of type. Oh my god. Cargo check. That's probably not going to work, is it? Expected struct memory pager found mutable reference. Doesn't have size known at compile time. All right. The trade stand marker size is not implemented for deno. Stand convert as mute. Blap. All right. So probably the thing that's going to happen here is that it's not going to be happy about the lifetimes of this stuff. So we have 3 different ways of initializing it, and here's our struct. Pub pages pager. Yeah, we can probably strip this out. I don't mind that. That can go. Right. So this will need to live for like that. Pub like that. Expected identifier found. So make some syntax errors here. Expected identifier. Pub struct bitfield. Unknown. Expected lifetime parameter. That was that. That was good. That was good. Expected type. And mute a pager. Oh my god. Oh, we can probably remove the unmute. Console is mute. Expected lifetime parameter. Pub create inner bitfield. Pub create inner 13. No. Oh, iter. There we go. Bitfield. Like that. Damn it. Impl bitfield 28. So this is just a giant like goose chase to check out where all of our things are missing. So 236 now we're missing. 236. Impl a default for bitfield of a. All right, more errors now because we just got through the borrow checker. So now there's a new wave of errors. Expected type and memory pager, found type and memory pager. All right. So that's line 36. So pager, page size. That pages equals that. And then we do pages equals and pages. Cargo check. Did that fix it? I don't know. Let's find out. So I'm feeling that this is the one flow in Rust that's reasonably common when you're trying to do like some more complex stuff, and having an IDE that was actually aware of this would be groundbreaking, because this is probably the hardest part in Rust, coming from other languages, is figuring out how lifetimes work, because you shouldn't have to be aware, except when you try and construct anything that's sufficiently complex, like what we're doing right now, and then you have to be aware 100%. It's just a lot of typing and messing around. It usually takes about like half an hour, so it kind of like drains a bit. And then at the end of it, you're like, cool, it now accepts 2 different types. And it's like, why? And it's like, it's just a better API, which is usually not a great answer. So that worked, because now we get to go to line 58. That pages equals pager from file, pages from file, pages, yeah. And pages. There we go. Cargo check. Line 65. 65 self inner. Oh, line 20? No, that's the iter. Line 20. Lifetime A required. Right. How does that work? Consider changing the type of inner to NA mut bitfield -a. We already did that. NA mut bitfield of A. Yeah, that's fair. Lifetime A required. Oh, I'm guessing. Wait, hold on. What did we just change? And B. All right, B. 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 Is this right? No, it's not. No, so bitfield is already like constraining it, which is good. So inner, does that solve it? No. Function associated item not found in iter. Item new not found. Iter rs 12, which just makes me guess that inner here is syntax error, which is not showing up right. Because now it's complaining about other stuff. Lifetime NA required. Does that solve it? Missing cursor, inner. Yeah, okay, so that's just another syntax error. Damn it. Damn it. And it's the freaking lifetime errors that like are really annoying. All right. So here, the size for values of type dan, stand, convert, as mute, memory, pager, pager plus stack cannot be known at compilation time. Yes, it can. Pub function from pages, pager doesn't have a size now at compile time. So as mute, pager does not have a size now at compile time. Is not going to implement it for, why is it not implemented? Stack over as mute, memory, pager, pager plus static. Ugh, that's just gross. All right, so the problem seems to be that our memory pager instance does not have a static size now at compile time, which in turn means that memory pager that this thing, that the as mute thing, is not having a good time parsing it because it doesn't know how to like handle it. So it's just not great. It's trying to sound convert as mute memory pager. I'm guessing it like assumes it's static, but it's not. All local variables must have a statically known size. But all we know is pointers. Dynamically sized. Okay, let's copy that. Let's go here. And let's not be able to access that. So let's go here again. We can't copy that, can we? xclip-app. Open. Xargs open. Dash open. God damn it! Come on. Open. xclip-in. Are you shitting me? Okay, we're gonna xdg open, xclip-out. There we go. That's what we wanted. All right. So something was up here. What do we need to? Dynamically sized types. Dynamically sized types. Due to Rust need to know certain details, such as how much space to allocate for a value of a particular type, there's a corner of its type system that can be confusing, the concept of dynamically sized types. Unsized types. Let's look into details of a thing. All right, so that makes sense. String slices, NT, string with all kinds of pointers, box string, RC string. T sized. All right, so this makes sense. So everything is by default sized, unless by default generic functions will only work on types that have a known size at compile time. However, you can use the following special syntax to relax this restriction. A trait bound on sized is the opposite of trait bound on sized. We would read this as T may or may not be sized. The syntax is only available for sized, not for other traits. Also note that we switch the type of T to T and T because the type reference might not be sized. We need to use it some kind of pointer. In this case, we've chosen a reference. All right, that's fine. All right, this makes a lot of sense again. But I don't know what's complaining still. I think I'm just too tired to do this. It's very complainy. But I don't know how to solve this right now. Also, hey everyone that just joined. Welcome to our sleepy stream. It's a Monday. We've been going for an hour. We're ready to call it a day. Yeah. So pages as mute from pager. So the main problem here is that I guess this is where I'm not sure how to do this lifetime stuff. No method named len. I guess there we go. So I actually need to do that. All right, so pages doesn't have size now at compile time. Because the asmute pager is not working. So instead, let's step one step back and say, yo, what happens when we do ref mute of thing. Map ref mute, standard cell ref mute. Use standard cell ref mute. From pager, ref mute of, what's the type here again? B1 ref mute of U32, car, C borrow mute. All right. They make this more complex than it should be, but this is a tuple, and we don't need tuple. All we need is like a single type, which is enough. And then, yeah, that's of type ref mute, which is okay. Course unsized. So 15, cargo check. I think we forgot a semicolon somewhere. Oh, we've got a double colon. Cargo check. All right. No method named asmute found for standard cell ref mute memory pager in the current scope. Okay. Pages as mute. That's funny. All right, so that means because we already have ref mute, I should remove that. Expect reference found thing and pages. Lifetime A required. Consider changing the type of pages to standard cell ref mute and a memory pager. All right, so if we borrow the pages here, then that seems to work. Rihanna says tired day here too. Sigh. Yeah. So this ref mute of a pages seems to work because it allows us to borrow it here. I'm hoping that ref mute secretly allows us to wrapper tap for immutably borrowed value from a ref cell. Probably won't though. Ugh. So from pager, pagers, and a pager, unused import, which I can live with. But then iter is our main thorn in the side right now, where line 19 and 20 are having a bad time. Iter new self. Iter inner self cursor 0. Let's see what happens here. Cargo check. Which means self. Yes, it did mean self. Damn it. Vim.lib 25.5. There we go. No. 225. There we go. Cargo check. All right, lots of errors. That's good. Counted for an appropriate lifetime for lifetime parameter A due to conflicting requirements. First, the lifetime cannot outlive the anonymous lifetime number 1 defined by 234. Note. Yeah, this is not helpful at all. But the lifetime must be valid for lifetime A as if I impl at 28.1. Expected mut bit field underscore found mut bit field of A. Explicit lifetime required in a type of inner. So that's a different error. So that the expression is assignable. Okay, so what does all this stuff mean? We should unpack this. So just a recap. I just pub fun new. I just commented, like, I replaced that one with a new method on the other thing in the hope that we would like get more errors, which we did. So now we're having this error where it says counted for an appropriate lifetime for lifetime parameter A due to conflicting requirements. So it says here, does that help? No, it doesn't. Iter 235. And mut A self. Unexpected lifetime A and pattern, unexpected lifetime. So the inner self, is that right? Yeah, it's that. Because the inner already has a lifetime. That doesn't work. Ugh. So I'm not sure. I'm not sure what's going on here. So the iter would take another thing. God, I just like want to kick back and sleep. I don't understand the error that's going on. Maybe someone on stream has like any idea. So there's an anonymous lifetime. Defined on the body at 224:3. So the thing that's happening is there is a lifetime. Like iter is being assigned a lifetime. So the reference does not outlive borrowed content, but the lifetime must be valid for lifetime A as defined. So there, we're messing up some form of lifetime stuff. We're giving the wrong lifetime and it's getting confused. I think that's what's up. So we're saying, hey, here's lifetime A. Please live for as long as this lifetime exists. And the thing itself is like, no. Which is a variation of the error we were seeing earlier. Here, saying, we're trying to tell it that bit field itself has that basically. Iter and bit field. So iter A lives there. So okay, so there's two lifetimes. One lifetime is attached to pager and the other one's attached to iter. So let's call that lifetime I. and lifetime P. Or actually one of these lifetimes is attached to the lifetime of the bit field. And the other one is attached to the lifetime of the pager. So B and P. So if we replace these lines again with that, and we replace these lines again with that, then we should be good again. Except here is a problem now. It says line 19 and line 20 explicit lifetime required. Cargo check. All right. Lifetime B is required there. Consider changing the type of inner B to nmut bitfield B. NB mut bitfield NB. NB mut bitfield NB. So that's already a type of inner. Welcome new follower. I've got a new follower. Awesome. Welcome. So here's the thing. I have like no idea whenever someone starts following because I don't get notifications on my screen. I think it's just like OBS that forwards it. So blah. So Rihanna says iter A has to live as long as the bitfield A it contains. Yes, it does. It does. No. Iter A has to live as long as the bitfield A it contains. Yes, but that's a minimum requirement. The bitfield A that's contained can live longer, has to live longer than the iter itself. Because if the bitfield goes out of scope while the iter still exists, that will point to null, which will break. Same with the bitfield. The bitfield needs to live shorter than the pager it contains for similar reasons. So here's the thing where I'm actually thinking that so the iter needs to live for as long as A and B, or the pager and the bitfield live, whereas the bitfield only needs to live for as long as the pager lives. And there seems to be some contention between those two. Oh, and that just solved it. Oh, it didn't. all right. So librs 224. Did we fuck this up again? Count in for appropriate lifetimes. All right. So lib iter new self. First, the lifetime cannot outlive the anonymous lifetime number 1 defined in methbot 224. So that the expression is assignable. But the lifetime must be valid for an A on the input at 28. So that the expression is assignable. All right, so we're gonna slash A. All right. Slash A slash P. Okay, so now that's the lifetime of pager. Cargo check, which makes it less confusing, right? Bum 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 bum. Bum 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 bum. I'm shifting a little bit more awake now. No notifications on Twitter. Okay. So expected bit field for the anonymous lifetime, but we found a bit field of lifetime P. So in this case, looks like cannot infer an appropriate lifetime for lifetime parameter B due to conflicting requirements. All right, first lifetime cannot live the anonymous lifetime number 1 to find a body at 224. So the expression is assignable. So iter new. So we need to say this iter needs to live for as long as the pager lives. Is that true? No, I don't know. No, also no. First, the lifetime cannot outlive the anonymous lifetime number 1 to find 224. So it can't live longer than that because it needs to be borrowed. Damn it, that's harsh. Which lifetime? So lifetime B cannot outlive the anonymous lifetime number 1 to find a method body. It's because we need to like just toss in an extra borrow there or something. Mismatch types. Cargo check. Found NN mute. Expected N mute bit field underscore. Found bit field P. B comma P. Unknown lifetime. All right. So let's think. Because I think we're passing in the wrong parameter. Simply said, that's what's happening. So by default, this thing seems to be passed the anonymous parameter as an unexpected lifetime parameter. So impl B, impl P, iter B, emma bit field B, at GD get diff source / iter. Did we add that second one there? Yeah, we did. All right. So this one is the second lifetime of P. The reference to it is of lifetime bit field, but the second one is of lifetime pager. And the second one is of lifetime pager again. And then iter B, P, like that. We're not using any of those. All right. And it doesn't matter anymore there because we're not using it there. All right, now we're gonna get weird ass errors, I think, where it's gonna be like, oh, expected 2 lifetime parameters, which is fine. So P, now we up, P, there we go. Cargo check. Expected lifetime parameter. Missing lifetime parameter. Underscore is a reserved lifetime name. Are you kidding me? Okay, fine. Fine. Cargo check. Expected 2 lifetime parameters. Pup phone iter. Liberis. Okay, okie dokie. So first it gets that. And it gets the second one can be inferred. Second one can be inferred. Please be inferred. Motherfucker. Give it the scope of this. Cargo check. Ah, fuck. So close. So close. All right. In type and B mut P reference has a longer lifetime than data it references. The pointer is valid. What does this say? I'm not giving up yet. I'm not giving up. In type NB bit field P, reference has a longer lifetime than data it references. The pointer is valid for lifetime B, but as defined in struct 12.1, but the reference data is only valid for lifetime P as defined under struct 12.1. So one is the bit field, the other one is the pages. In type B, bit field P, reference has a longer lifetime than the data it references. All right, hold on. So maybe if we just cheat. Fuck. The pointer is valid for lifetime P as defined as struct 12.1. Hold on, I think this might actually be good. But then we go here and then we say put an iter. What if we switch these ones around? That's for as long as a pager, and that's for as long as the other one. The reference has a longer lifetime than the data it references. The pointer is valid for lifetime B as defined as struct 12.1. Come on. It says, okay, so the error here is we have two lifetimes and they're both valid for equal amounts of time, but the compiler is like, no, you're valid for different amounts of time. What do you mean longer lifetime? MPB. So pages. Okay, let's do it in order of ascending stuff. I'm thinking because of the order, it might actually matter. So RP, RB. So pages first, right? B, P, B. Okay. Implement P for pager. And then here it's indeed pager. And this is for as long as we live. All right. The pointer is valid for lifetime B as defined as struct 12.1. But the reference data is only valid for the P. All right, so the pointer into it. So the is that. All right, so I think both of them need to be valid for as long as B is valid for. RP, FP. Cargo check. Unused type parameter. Pub struct iter 12. 12. Are you shitting me? Found reserved identifier. Get. Wrong number of lifetime parameters. This is annoying. This is so annoying. Is there like a way we can set these together? I don't want to ditch the iterator because we really need the iterator. Let's commit this actually. All right, let's take a look. So the cursor can live for as long as it wants. Yeah, so a bit field should live for as long as the pager does, and the pointer into the bit field itself should live for as long as the bit field does. But in this case, the bit field itself should exist for a particular amount of time already, so it has a private pointer into it. That's what I'm thinking. At which point, none of this makes sense anymore. So all we need from this is yeah, god damn it. Okay, we can remove all these. I'm not happy about this because it feels like we're going back to square one. Lib, and I'll go back here. Cargo check. So this lifetime parameter should already be specified. Can we just say like this thing should live for however long this should live? Yeah, it doesn't like that. Can we just be like, it's a mutable reference that doesn't have lifetime? No, it really wants that lifetime there. All right, so it also really wants that lifetime there. And that starts complaining again. Ugh. Ugh. All right, so kind of for an appropriate lifetime for lifetime parameter B, sort of back where we started. First, the lifetime cannot outlive the anonymous lifetime number one defined method by 224. So a return type of this gets a lifetime attached to it, which is anonymous. So the lifetime cannot outlive the anonymous lifetime. Yeah, so that's a problem. Because it literally does. Ugh. Rust lifetime live anonymous lifetime. All right, so here's a problem, which seems like we have it. Build and write reference for self-argument of a method. An A, pop front, a B, an A. Oh, motherfuckers. Yeah, that's amazing. Here we just named previously anonymous lifetime number one to be able to bound to it, saying that it has to outlive an A, longer than A. Oh my god. All right, so there's a fun trick here where we can assign lifetimes to our lifetimes, which is maybe what we should employ. All right. So problem is not so much there, the problem is more here. I B. Curve check? No? Black. Found iter. First, the lifetime cannot outlive the other lifetime. And B mute self. Yeah, that's not gonna fly. Itself should be shorter than NA. So that can be enforced that it's always shorter than pages. So the lifetime of buffer is shorter than what pages. Where this one is the lifetime of pages, and that was the lifetime of the bit field. It still doesn't like it. Expected element bit field underscore found element bit field P. $224 itery. Puff on iter BP self, so the expression is assignable. Expected iter B. Yeah, it's literally just me debugging stuff. I'm sorry if it's not the most entertaining. All right. So lifetime issues, like I feel they're trying really hard to give us good things, like good help, but it's like not enough help. Like when they say, but the lifetime, which lifetime? What lifetime? The word lifetime's being thrown around so much that I'm like a little bit confused now. Like which lifetime? First, the lifetime cannot outlive the lifetime P as defined in impl 28.1. So which one was it? The anonymous one here, right? The P right there. Which one is that? But the lifetime must be valid for lifetime B as defined on method body. So I'm guessing the appropriate lifetime cannot be inferred. But the thing is, I'm thinking in terms of variables, not so much in terms of, oh, what's the actual lifetime. It's like two meanings to the same word. For lifetime B is defined on method body 224. Expected element bit field found element bit field P. Impl P bit field P. First P. So this already has that one lifetime. So my hope this would say is B lives shorter than P, but it's still like, no, P can like live way longer. All right, let's take more time to read this. So what are they doing? Pull on A memory pool. So I can write into it. It takes the A. And it also takes a buffer byte array of A. Vec self pool consume v let buffer set data. Right. Autoref describes the method. The compiler is unable to find a reference with the right lifetime to consume. Why is it unable? Norm's lifetime 1 versus lifetime of n itself. This notice is just saying we can't pass a reference with the lifetime greater than the lifetime of self into consume. Then consume would think that its self argument lives longer than it actually does. All right. Maybe this is it. No, it's not. Yeah, it's also not good. Because here we're just flipping it around. It's like starting to complain about the other side of borrowing. So borrowed value does not live long enough. Source lib, pages 37. Where we're trying to say like, hey, it should always like live shorter than the other one. This is the better error, probably. Like this is closer to where we want to be, but it's still like one problem. So nmod self right there. Iter new self is what we're passing down there. And we're returning an iter of b. Should we though? No, iter of b is actually good. Iter of b is great. Because p gets self already has that lifetime on it, and the return type has the other lifetime on it, so that should be good. But it's not. Oh, and then the problem is that we're passing the lifetime of that all the way to the bit field. Oh my god. Okay, so what happens when we BP 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 fuck. We're back here, aren't we? Oh. So what you just saw was a hex editor, which is super useful, except not now. There we go. Cargo check again. Expected 2 lifetime parameters, B and P. Ugh, still no good. The pointer is valid for lifetime B as defined as struct 21, but the reference data is only valid for lifetime P as defined as struct 12. Dot 1, boarding that. Yeah, there we go. So the pointer, it's annoying because the we're literally trying to tell a compiler that pointer side for left-hand B as the final stroke 12.1. But reference data is only 5. That's annoying, that's annoying, that's annoying. So what happens when we flip these around? Like there's no version in which we can define these where one or the other lives longer. Okay, I think I'm gonna abort this. I'm gonna like ask some people to actually know what's up. Some other point. Welcome to the wonderful world of debugging stuff. You know what? I like this version best. BP. No, it's the other way around. Hey, Jesse. How you doing? Cargo check. All right, so this doesn't work at all. Lifetimes, yay. Push. There we go. Okay, this doesn't work, but at least it's enough to ask friends how we should fix this. Work in progress, lifetimes. Lifetimes aren't going great. Great yet. Jesse says he's good. How have I been? Yeah, I was complaining about how sleepy I am right now. Otherwise good. Had like a really chilled out weekend with cats and dogs and friends and one bike crash. Which luckily it wasn't me, but yeah, just all right. That's to create an instance from a what? From a shared memory pager. There we go. Awesome. Oh, we need to rebase it. Master go from pager. Rebase I master parse push. Okay. Okay, so we can close all these. Oh, yeah. All right. Okay. Let's take a little ponder. Should probably take like a 2-minute break or something. But I'm afraid my computer might like crash again. What should we work on? I feel like this was my work part for a day, which required a lot of attention, but I haven't like been able to fix it. There's not too much other stuff that needs doing. A little bit, but not heaps. Boom, 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 boom. All right, let's take a little look here. Rihanna says, here's a cool game. Cool. Descenders. That looks like fun. Little biking game, going downhill. Looks pretty fun. play as Spider-Man, the Spider Bike. Yeah, it looks fun. Oh, by Crash. Lol. I feel like Tramline Tycoon would be an appropriate one. Also, all right, let's take a little ponder. I can show you my secret fun side project I've been working on. I'll grab June, Jill, there we go. Futures supervisor. So this is a project that I haven't like really shown anyone or talked about much, but I think it's kind of fun. It's unreleased because I didn't want to have like anyone up my back being like, blah, why are you building this? You're wrong. You can't do that. And like I just want to mess around with stuff. So the short version is I've been looking a bit into Erlang. It's a lot of fun. All right. I should probably explain this. So I don't write servers, but I like to think about servers because servers are pretty simple usually. They're very well defined problems. Like a request comes in, you do some form of transform, you do some form of like branching, perhaps like request out to a backend of sorts. Perhaps like you send an event off into like an event queue, and then eventually you send back a response. It's easy to think about. It's a giant transform function with possible side effects. That's what you define as a server. Like most money people make writing backends is done. There's a lot of it being done with stuff like that. There's a lot of stuff being done to keep those servers up and all sorts of other servers. It's mostly servers. It's mostly transform functions, and altogether, yeah, it's very straightforward. But fuck, I'm trying to find like a good story here. Basically, I think Erlang is really interesting. That's a poor name right there. Erlang is interesting because it was built, I believe, somewhere in the 80s when telephony like when mainframe computers were a thing and telephony networks were like up and up and up. And they were like, hey, we need to figure out a way to make our systems like hyper reliable. Because if we don't make them reliable, governments will fine us and they won't like us and we'll get into trouble. So, you know, we need to, it was the Ericsson company. They were like, oh, fuck, we need to figure out ways to keep our stuff up all the time. And basically what Erlang did back in the day is pioneer a lot of the stuff that these days we call distributed systems. But they took it from a language approach. So they were like, okay, cool. One of the principles they had was decoupling. So how can we have like have these mainframes run lots of tiny programs that if one of them crashes, it's okay, you know, the whole system doesn't go down, because that's the way a lot of programs are written these days. Still, like one part goes down, the whole thing goes down, and then the whole program needs to be rebooted, and that's not great. So with Erlang, they were like, cool, let's take the idea of processes and like process IDs and create like a pub sub event emitter style thing with like a giant VM and like lots of programs. And then you can swap out the little programs and redeploy them basically the way like people think about Kubernetes by the language level. And they were like way ahead of their time, like 20 years early, 30 years early. So that's really fun. And a thing that when people talk about Erlang, they oftentimes two things come up. The first one is the OTP library, and the second one is supervisors. Now the OTP library is kind of like the standard lib kind of thing. I don't know exactly what the scope is, but I like to think of it that way. Also, disclaimer: I've never done Erlang. I've just read and heard and listened to stuff about Erlang. But then, like you can see here, more information: supervisor behavior and OTP design principles. Blah blah blah. The one true pairing library. I wouldn't be surprised if that's actually what it's called. I really don't know what it stands for. But the supervisors thing is another very important thing. So the way supervisors work is you can think of it as a little bit of code is run, right? Say we have a HTTP server and we have a login portion, and that login portion in turn has I don't know, it calls out to a database or something, right? Whatever. Erlang authors love fan fiction. I don't know, like the fuck, I can't make a good analogy here. But basically the idea is that if any part of your program fails, it doesn't take down the whole system. Instead, what we'll try and do is do retries, right? Say we're doing a piece of code that's like making a request somewhere, right? It's connecting to a database. Like it tries to like write to a database and says, "Oh, I'm writing to the database." And it tries to write, and then like boom, bah, like critical error. Like that piece of code like goes down, and it's like fuck. And the piece of code above it will be like, okay, cool. We should probably try and reboot this. And it like tries to reboot it, right? And maybe it'll work, maybe it won't work. Maybe it'll work for a little bit and then fail again. So by default, the Erlang has 5, tolerates one error, one critical error over a span of 5 seconds. And if more than one error occurs in a time frame, like a sliding time frame of 5 seconds, he'll be like, okay, that's it. Too many errors. You can adjust this number, by the way. Too many errors. Apparently the part under me is failing consistently. I don't know how to reboot this. I can't get it to work. So I am going to shut myself down, and I'm going to let the supervisor above me resolve this situation, right? And so you create like a tree structure of how to handle failures. So that part, that piece of code that's like now deciding to shut down might be responsible for more pieces of code. So it might be like, hey, you know what? All of us like need to shut down now. Like this is bad, right? And it'll like propagate the error upward. And like the piece above it will be like, oh, okay, cool. So it shut down once. Maybe like let's pull the plug and plug it back in again, and let's see if it works. Right? And this might have a larger sliding window. Maybe it's like I'll tolerate only one error of this type in 10 seconds, right? So if this happens more often, then you know that breaks down. And you create layers and layers and layers. And the idea is to structure a program in a way where you have how do you say that? Functional differences. So hold on. So the example I heard that I really liked, it probably applies more to Erlang than to Rust, but we'll take it to Rust in a bit. Is say we're building a program that manages a fridge, like one of those vending machines with like little cans of soda and water and whatever, right? Then we can think of like, okay, cool. What are different parts? Say the payment system stops working. Should we also take offline the power supply system and the cooling system? The answer is like probably not. But what if the power supply system goes offline? Should we take down the cooling system also? The answer is yeah, probably we should, right? Maybe those are one and the same. Maybe they're different parts. There's a hierarchy there, right? Like the cooling system and the payment system, they're siblings. If one of them goes offline, the other one doesn't need to. Or actually, if the cooling system goes offline, the payment system should also. But if the payment goes offline, the cooling does not, right? So there's a hierarchy there. If the power supply, something in the management goes wrong, then all the systems need to go offline, and we need to shut down the whole thing, because otherwise, that's bad. usually. Also, there's different rows of products, right? And what if one of the spirally things breaks, doesn't respond anymore? Should we take everything offline? Should we take just a whole row offline? How do we manage that? And by thinking of it in such a way, we can start like structuring our program in different levels of hierarchy, like which parts are siblings, which parts should be taken offline when, what constitutes a critical failure for the whole system, what's like the different domains. And you would then start structuring that from there using supervisors and be like, okay, cool, here's a different subsection. If this part goes offline, this other part also. And it very much defines the relationships between the things. Now, at the very top part, if something breaks, I say that I guess your process goes offline. If your process goes offline at the top level, you might have like a retryer that like tries and reschedules it and puts it online again. Right? So there's always like the levels and gradations already exist in real life, but usually we just have more or less a try catch everything and reboot the whole process forever kind of situation, which is less explicit, I guess. Let me think. Oh yeah, the Rust part. So the way this works in Rust is, unlike Erlang, we don't have a giant VM. Also, unlike Erlang, we don't have how do you say this? A runtime. We don't have processes. We don't have an event emitter. We can't have all these things that run and everything can send like messages to everything else. So that's not the case, right? Instead, what we do have is the same ideas of, hierarchy of processes. Even with microservices, we will have that hierarchy of processes, even within a single application. Unless you're building the smallest possible microservices, at which point I'm like, okay, sure, maybe not in that case. But in most of every other case, there will be like a rather big hierarchy inside of a single app, mostly, usually. Right. So the idea here is that we're able to create a supervisor here with different types. I'm just copying all the Erlang lingo, where you have a transient. You have like either permanent processes, transient processes, temporary processes, which have different semantics of whether or not they should be restarted. Different ways in which they should be shut down, different ways in which we can detect that they should be shut down. And I'm just trying to write a little library around that. So here is, we create a new supervisor with intensity and period, and we attach 3 transient processes to it. And all of these can like exit correctly, and then the supervisor, this future, will also exit correctly. That's basically the idea. And that's like one version of it. Then the other more common version, which I kind of want to do, is a .supervisor method, where, for example, here is the let server TCP listener, blah, blah, blah. All right, so here's another crate, which I thought was really interesting, which almost does what we wanted to do, but doesn't quite do that. So this does is it allows you to create a error handling policy, which allows you to retry something. So it says, well, if the error was interrupted, then we should repeat. If the error was permission denied, then we should just fail. And if the error was a retry, right, then we just wait 5 milliseconds. You can make this more complicated with like jitter and exponential backoff and all that stuff, right? But the thing is, like, hypothetically, what if what if it infinitely keeps telling us IO error kind interrupted? It will like forever keep on retrying, right? There is no point at which it's like, no, I'm done. So this only works for very simple situations, but doesn't have the flexibility of a full-fledged supervisor, which is more formal. It has like 30 years of like baggage of strategies on how to handle retries. But this is very useful because you might like want to use this on anything, right? So you just say .retry handle error and then stream. Right, so in this case, we might do that server incoming instead of like .retry. We say .supervise. We give it a default supervisor. It's like, here's your supervisor. It's gonna create like a transient thing. It's just gonna retry it a couple times, and if it can't retry it within that 5-second period, that's gonna crash, and it's gonna be like, okay, cool, that was it. That was the error. Now it failed, and that's it. That's all. And then here, it just goes on. It's otherwise very much the same. But so this idea I had for very short, very much inline error handling, whereas the other one is more formal for like bigger things. What if we have a connection pool on the one side and like some other stuff on the other side, and here's like an external connection to another service, which is just a live pipe. How do we handle it when those things go offline? What if our database is no longer writable? One of the cats got awake. Oh, damn. Hey. Oh. So this is Chashu. She's a little bit sleepy. Say hello. Yeah. That's my little baby. And she's really sleepy right now. She just woke up, so she's tolerating everything. She's just curling back up. But yeah, I hope all of this makes sense. Specifically, like taking notes from Erlang, it may or may not be a good idea. Because I don't build servers, right? All I'm doing is like theorizing about it and thinking like, I think this might come in like really useful. Because one of the things that is tricky. Oh my god, I'm getting like a dry throat, so I'm just like, itchy. But one of the things that is super tricky in general is how do you handle errors correctly, which has many. Oh my god. Someone really wants cuddles. And my hand is getting licked, which is not bad either. No, so like just error handling is a big deal. So the thing is, you want to know when your program doesn't work. So on one side, you want logging in different levels. You want to report back to users when things don't work. You want to I don't know, make sure you retry and you don't instantly take down your whole system all the time, but also take it down when it actually doesn't work. There's so much to error handling. You want to provide the right levels of context. I've never gotten this many meows. I think it's because I'm talking and she doesn't know who I'm talking to. I know. And I think supervisors might solve a very particular use case. Specifically in the try real hard before you give up side of things, but actually do give up if things don't work out. In a way, it's a very fancy version of a promise.all, or a future.all. Oh my god. Little kitty over here. Rihanna says, I think Chashu might have some good insights about supervisors also. Yeah, I think so too. I think she's supervising the situation right now and making sure that all the future is resolved correctly. I hope you got to hear a bit of the purring there. She only does that when she just wakes up or when she's like really sleepy. Not many other times. Boom, 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 boom. Yeah. So I was thinking maybe like hacking a bit on this supervisor stuff. But on the other hand, I'm kind of sleepy. And the cats will really want attention. And we've been going for 2 hours. So maybe I should just like call it quits. But there's an update on what I'm doing right now. Oops. Which I hope was like interesting enough. So yeah, I think I need to be a bit more cat dad right now. It's one of my daughters really wants attention, so I'm gonna log off. But it's been fun. Like for the first time in like months, we've done like a proper 2 hour stream, which I'm really happy about because it usually turns out to be 3, 4, and then I'm like super sleepy. Say hello to the people on stream. Hello everyone. All right. So I think that's it for today. Thanks everyone for joining us. Could you wave goodbye? Bye bye. Okay. Now I need to find a way to stop the broadcast with one hand, which I'm gonna do right now. See y'all later.